Good morning, class. Welcome to geometry class via the video camera. Go ahead and open up in your books to lesson 101 on page 656. Hopefully you did well on your homework that you've checked. And as we're turning there to lesson 101, let's review the three types of lines we have talked about regarding circles. One is a tangent that touches a circle at one point. One is a secant that goes through the circle, intersecting at 2 points and goes beyond the circle. Another one that we've learned is also our chord. A chord has its endpoints. It's a line segment that has its endpoints on the circle. Again, different from the secant. The secant continues on beyond the circle and the chord stops here. We're going to be focusing on the tangent and a secant today and how to determine their measures. Let's look first at two secants. When I have two secants, these are always going to be, we're talking about secants and tangents that intersect outside of the circle. They intersect at a common point here. Not just two random secants within a circle, but two secants that intersect at an external point outside of the circle. They're going to be the products of each other. Look closely at how we find these products. It is going to be AB, which is this external segment here, times AC. Notice that is from the external point all the way to the second intersecting point here. The first one is this first piece, AB, AC, not BC, all the way through. AC equals the same thing on this lower secant. AD, the external piece, times AE, all the way through from the external point all the way through to the second end point. That is how we can find the measures for secants. That's how we can find the measures for secants. This external segment times the whole length of the segment. This external segment times the whole length of the secant. Not just DE. This is not included here. So if I was given this piece of 3 and this piece of 7, it would be 3 times, not 7, but 10. I'm taking the whole segment there, 3 plus the 7, giving us that product. The external segment and the internal segment, the whole segment. Let's look at two tangents, a secant and a tangent. A secant and a tangent are also going to be very, very similar. It is from the external point to the tangent point. Now look this time, we only have one point there. So it is AB times AB, which is AB squared. Again, we have a tangent and a secant intersecting at a common point outside of the circle. Since we don't have two endpoints, we're going from this point to here. It's going to be AB squared equals, just like we did before, AC, the external segment, times AD, the whole segment from the external point to the second point of intersection, AD. Again, AB squared for the tangent section squared is to the external segment times the whole segment. Once again, like we mentioned before, if this were 3 and this were 7, we are multiplying 3 times, not 7, but 10. This whole length here from the intersecting point, the farthest one, to the external point. Let's go ahead and practice one of these from your book. If you look at example 1 on page 656, you'll see that we have a circle with two secants. They're intersecting at point Q. They're intersecting at point Q. We've got S here, T here, point R outside of here, and this is point Q actually, and this is point P. All right, let's fill in the measures here that they gave us. They gave us 27. They gave us 3. We're trying to find this segment here. Here's our unknown. And this segment is 9. So let's see how we're going to set this up. We don't know the external segment, so that's going to affect our internal segment here as well. It's going to affect our internal segment because remember, it's not the 9, it is from 9 plus the x. So we're going to have 27 times, not 3,